Now, how can we find the vertical asymptote of f of x? Now, first, let's take f of x to be equal to y. And to find the vertical asymptote, we simply equate the denominator of the function to 0. So x minus 2 is equal to 0. We add 2 to both sides of the equation, and we get x being equal to 2. Now, how can we graph this function? First of all, we have to assume these were two straight lines, right? So to find the vertical asymptote, we have to input some values of x. Now take note, from the right, the function can either go this way or that way, right? And we can determine this by inputting certain values of x and y. So taking the value of x as 3, we get f of x or y being equal to 1 on 3 minus 2, right? So y is equal to 1 when x is equal to 3. So when x is equal to 3, first let's draw our vertical asymptote, which of course is a straight line. Let's represent that by a dot. So this is x is equal to 1. Let's put x is equal to 2 over here. This is our vertical asymptote at x equal to 2. So when x is equal to 3, right, y is equal to 1. So we obtain this point. So we can clearly tell that the curve goes this way, passes through this point, and curves to the right, right? Now let's input in other values of x to determine if the curve goes this way or the curve goes that way, right? And remember, we are still making assumptions that my curves are actually smooth. So let's input the value of x as negative 1. Sorry, as 1. So we obtain y is equal to 1 on 1 minus 2, which gives us the value of y as negative 1. So we obtain the point 1, which is the x value, and negative 1 as the y value. Excuse me. So 1 for the x value, which we have over here, and for the y value we have negative 1. So the point will be somewhere in this region, right? So drawing our vertical asymptote from the left, we obtain a curve which goes like this, passes through this point and branches down. And this curve doesn't cross this line, and that's why it's called vertical asymptote. Now let's work on more examples. Now we have a very interesting question, right? We have f of x being equal to 7 on the denominator, x squared plus 9 equates our denominator to 0, and we get x squared plus 9 is equal to 0. We subtract 9 from both sides of our equation, and we get x squared is equal to negative 9. We can factorize the negative out, giving us 9 multiplying negative 1, right? So finding the square root of both sides of our equation, we get x squared being equal to plus or minus 3i. Now maybe this is new to you, but take note that the square root of negative 1 is equal to I, right? Sorry, let's cancel our square over there because we took the square root of x squared. So now we get x, which is the vertical asymptote, being equal to 3i or negative 3i. And since the value we have obtained is a complex number, the vertical asymptote does not exist, right? Does not exist. Now let's take this last example. Again, we have a very interesting example. So enough of f of x, let's take g of x, right? So we have g of x being equal to 2x squared plus 4x minus 6 on the denominator. Let's take x squared plus x minus 2, right? Now pause this video and please try it out. Okay, so let's continue. We can factorize our numerator as 2 multiplying the expression x minus 1 multiplying x plus 3, right? And also similarly factorize our denominator as x minus 1 multiplying x plus 2. So we can cancel out x minus 1 in both our numerator and denominator, leaving us with the expression 2 multiplying x plus 3 on the denominator x plus 2, right? Now we have to take note of this 2 is very, very important, and that's the main reason why I actually brought up this example. Now we will be taking horizontal asymptotes in later videos, and it's important we know how to factorize. Now, what's the difference between punching 2x squared plus 4x minus 6 on the calculator and x squared minus plus 2x minus 3 on the calculator? So please pause the video and again try it out. Now we would see that punching both of this and that on your calculator gives us the answer as x minus 1 multiplying x plus 3, right? And takes away these 2. This is because when we punch 2x squared plus 4x minus 6 on the calculator, we punch it as an equation, right? We punch this as an equation. So the calculator simply divides both sides of the equation by 2, resulting in this equation, right? And later does the factorization. So we have to take note before we punch any expression on the calculator, like by factorizing the factor out before we punch it on the calculator to avoid making certain mistakes, as in this example, right? So let's get back to business. We again equate our denominator to 0. So we have x plus 2 is equal to 0. Then we obtain x as negative 2. So this is our vertical